This is our next lecture of chapter 1, class 9th mathematics, the number system. In this lecture we are going to discuss about the representation of real numbers on the number line. So in the first part we represent the number square root 2, square root 3, square root 5 on the real number line. To represent square root 2 we have the following procedure. So how we start drawing this number is that first of all we draw a horizontal line and we mark a point O on it and we call this point as 0. This is our point 0. Then we mark a point A at a distance of unit length from this point O, just as we do in case of real number lines. In the case of integers we have drawn this, in case of rational numbers we have done the same. Now we are drawing the irrational number square root 2. So when we have done this, then the next step is we have to draw a perpendicular at this point A. We have to draw perpendicular at A, and length of this perpendicular is also 1. So what basically we have obtained is, we have obtained this OA is of length 1 and this point B is there. This length is also 1. If I join O and B, then using the Pythagoras theorem, the length of this OB is 1 square plus 1 square. So we are saying that this is the length square root 2. Now we have to draw this square root 2 length on the number line. To draw this on the number line, we open the compass over here. This is our length square root 2. We keep our compass over here and we draw a circle with this radius. We keep one end at this point, second end at this point, and we draw the circle over here, the arc over here, not the circle, it is the arc over here, and we cut at this point and we say that this point is point P, and this point P will represent the point square root 2. So this is how we can represent square root 2 on the number line. Now the next is we have to draw square root 3. So to draw square root 3, what we are going to do is, now we are having this length is square root 2. Now at this point B and on this line OB, we draw another perpendicular over here. This perpendicular we are drawing on OB. At the point B, we have drawn the perpendicular BC. The length of this perpendicular is again 1. So what we get is, we are getting a triangle over here like this. This is the point O, this is the point B, this length is square root 2, this length is 1, and we are calling this point as C. This point is C. If I join OC, it is right angled over here. We have drawn the perpendicular at this point B. So what we get is, this length is square root 2 square plus 1 square and under root. So the value is square root of 2 plus 1, that is equal to square root of 3. It means if I join O and C, the length of OC will be square root of 3. Now I have to mark the point on the number line. So again what we are going to do, we will keep the compass at point O, we will keep the compass at point C, and we will draw the arc over here of this much radius, and we obtain another point over here, and we are saying this point is Q and this point is representing square root of 3. Now in the next step, if suppose we have to draw square root 4. Square root 4 means we are talking about the number point O, this is the point B, this length is square root 2, this length is 1, and we are calling this point as C. This point is C. If I join OC, it is right angled over here. We have drawn the perpendicular at this point B. So what we get is this length is square root 2 square plus 1 square and under root. So the value is square root of 2 plus 1, that is equal to square root of 3. It means if I join O and C, the length of OC will be square root of 3. Now I have to mark the point on the number line. So again what we are going to do, we will keep the compass at point O, we will keep the compass at point C, and we will draw the arc over here of this much radius, and we obtain another point over here, and we are saying this point is Q and this point is representing square root of 3. Now in the next step, if suppose we have to draw square root 4, square root 4 means we are talking about the number 2. So what we are saying is, we have started from, this is our point 0 O, then we have marked the point A. On A we have drawn a perpendicular, this is the perpendicular on A. Then we have joined these 2 points, this is our point B, and we are saying this is the length square root 2. Then we draw a perpendicular at this point B, we join these 2 points, this is of unit length, this is of unit length, we are saying this is the length root 3, and we are saying this point is C. Next what we will do, we will draw the perpendicular over here, we call this point as D, we will join these 2 points and this length will be 4. Next again we draw the perpendicular over here, we join these 2 points and this will be the length square root 5. Then next step, we have already drawn the circles arcs over here, and corresponding to these arcs we will get the corresponding points, that is square root 2, square root 3, square root 4, that is 2, square root 5. Likewise we can continue in this way and we can obtain square root 6, square root 7 and so on. So we are saying that in the same way we can locate square root n for any positive integer n after n minus 1 has been located. If the square root of n minus 1 is located, then the next point we can draw in this way. The same thing is represented in this diagram. This diagram that is given to us, we have given this point is O, then root 2, root 3, root 5, and this is the point B, this is the point C, D and E. So what we are saying, this is basically the length root 2, this is the length root 3, this is the length root 4, this is root 5, this is 1, 1, 1 and 1. So in our previous slide, we have drawn all the numbers of the form square root n, where n is a natural number or a whole number, you can say. Now next we are talking about, we can draw square root x, where x is any positive real number, where x is any positive real number. So what is the procedure to draw that is, we are saying that first thing we have to do is, the first step is, we will draw again a line of length x units, this is the line of length x units we are saying, and we are saying this is the A, B. If suppose we have to draw the number square root 7, so what we are going to do, we will draw the line of length 7. One procedure is that we have already adopted in the previous slide, that you draw square root 1, square root 2, square root 3, square root 4, square root 5, square root 6, then you will reach up to square root 7. So in place of that, what we can do is, we can just start with this, that we draw a line of length 7 and we are saying this is A, B. In the next step, we extend this line by a unit length. This is 1 unit length and we are saying this point is C. Irrespective of value of x, we will extend this line by a unit length and we call this point as C. Then in the next step, what we are going to do, we will take the compass and we will bisect. We will find the midpoint of this. So we will keep the compass at these points, endpoints, and we will mark the points like this. You will get the midpoint of AC. We are finding the midpoint of AC. We are not finding the midpoint of AB, we are finding the midpoint of AC. We have started with A, B as line, we extend that line to C, and the length of BC is 1 unit. Then we have marked a point O, and we are saying this is the midpoint of AC. Now the next thing we have to draw is, we have to draw a semicircle with center O and radius AO, or you can say diameter AC. So when we draw a semicircle over here, this is the semicircle. This O is the midpoint, or you can say the center of this semicircle, and we have drawn this circle. Now what we have to do, the next step is, we have to draw a perpendicular at B. We draw a perpendicular at B and we join this point O and D. Now we claim that this length BD is square root of X. I am again explaining the procedure. The first step we have to do is, we have marked or drawn this line AB. We extend this line AB by a line of length 1 unit. This is line of length 1 unit. We have extended this. This is midpoint of AC. This point O is the midpoint of AC. Then we draw a circle with the center. We have taken, this is the center and this is the OA is the radius of this circle. Next step we are saying is, we are drawing a perpendicular on this B. At this point B we have drawn the perpendicular, and where this intersects this circle, we are calling this point as point D, and we are claiming that this distance BD is square root X. Now how we will mark this on the line? We will keep the compass at this point B and draw the circle with radius BD. So basically we are saying the circle that is shown over here, this circle, we are saying its center is this and its radius is BD. So this distance BE is basically square root of X. Now we are claiming that the distance BD is square root of X, and we have to prove this statement that this distance is square root of X. So what we are saying is that the distance AB is X. This distance AB we have considered, it is AB is of length X, BC is of length 1 unit. It means AC is of length X plus 1 units. Now OD we are talking about, that is equal to OC, that is radius of this circle, and we are saying this is half of AC. So this distance we are talking about, this is X plus 1 by 2. This distance is X plus 1 by 2, and this OD is also X plus 1 by 2. We are saying these distances, these three distances, this is X plus 1 by 2. Now if we have to find this length OB, we are talking about this length OB, we are saying OC is of length x plus 1 by 2. This much is the length 1. So what we are left over here is this length is x plus 1 by 2 minus 1 units. So we are saying this length OB is x plus 1 by 2 minus 1 units. So on solving this, you will get that this is 1 by 2 x minus 1 units. So now we have a triangle with us, and that triangle is in this form, and we are saying that we are talking about this triangle. We are having a triangle. This is O, this is B, and this is D. This is the length we are talking about. This we have to calculate. BD we have to calculate. OD we have x plus 1 by 2, and OB we have is 1 by 2 into x minus 1. So to calculate BD, we have to do is square root of OD square minus OB square. And when you make these calculations, when you solve these values, you will get that the BD square, or the value of BD, is square root of x. So we are saying we have proved that this length BD is square root x. Now on the similar lines, we have to suppose we have to represent the number square root of 8.47 on the real line. So what is the procedure? First thing we have to do is we have to draw a line of length 8.47 units length. Next we extend this line with 1 unit length. The next step we have to do is this line we have drawn over here, we are saying these points are A and B. We have extended this line to the point with a unit length, and we have extended it to the point C. The next step we have to do is we have to find the midpoint of AC. Suppose the midpoint of AC is O, then with O as the center and OA as radius, we draw the semicircle. This is the semicircle we have drawn over here. Then from B we have to draw a perpendicular, and we are saying that this point is D. Then from this, by taking B as the center and this as radius, we draw a semicircle over here. This semicircle we have drawn, this radius and center, this is for this circle, and we are saying that this point E over here, we are saying this distance, either this distance you say or BE distance you say, both these distances, these are of the length square root of 8.47. So we can use this procedure to draw any real number on the number line, square root of any real number on the number line. Now next is an interesting topic with us, and it is representing real numbers on the number line using the successive magnification. So in this topic, first thing we have to do is we have to locate the point 3.895 on the number line. We have to locate this point on the number line. So how we start doing this is, we have considered the number line. First thing we know about this point is, we are talking about the point 3.895. It means it is 3 plus 0.895. Further, I can write it like 3 plus 0.8 plus 0.09 plus 0.005. So first thing I am going to do is I am going to locate 3. We have located the point 3 on the number line. It means we are saying it is after 3 and before 4. It is between 3 and 4. So what we do is we magnify this much region, this 3 to 4 region, we magnify it, and we have drawn this second line. Now it is 0.8. It means I am dividing this part in 10 parts. Between 3 and 4, I have taken the interval between 3 and 4 and I have divided it in 10 parts, and I am talking about the 8th part over here. So what we have done, we have taken, this is the point 3 now, and this is the point 4. This is the point 3 and this is the point 4. We have magnified this region. We have divided it in 10 parts. On dividing this region in 10 parts, the 8th part we are talking about, this is 3.8. Now what we know is that this point 3.895, this lies after first step. In the first step we are saying it lies after 3 and before 4. In the second step we are saying it is lying between 3 and 4, it is lying between 3.8 and 3.9. So we magnify this region 3.8 to 3.9. When we magnify this region, this point we are saying this is 3.8 and this point we are saying this is 3.9. Again we divide it in 10 parts. Now the next part is 3.89. So 3.89 will lie between 3.89, we are having 3.891. So we are saying that we have located the point 3.89. So it will lie between 3.89 and 3.9. It will lie between these 2 points. So we magnify this portion now. It is 3.89 and this is 3.9. And we have magnified this portion now. This is the point 3.89 and this is the point 3.9. We magnify this portion and we have again divided it in 10 parts. Now it is the point 0.05 and this is the 5th part over here. So what we are saying, basically what we have done, this is 3 to 4. Then over here somewhere it will be 3.8 and 3.9. In 3.8 and 3.9 there will be 3.895 and 3.9. In between these 2 points we are saying 3.895 will lie. So what we have done, we have started with this line between 3 and 4. We have magnified it, divided it in 10 parts. Again we have magnified it, divided it in 10 parts, and again we have magnified it and divided it in 10 parts. Now in the next case, again the similar example is there, but now the decimal representation that is given to us, that is non-terminating but repeating decimal number. So the number we have now is 2.3222 and so on. So what we are saying, it is 2 plus 0.3 plus 0.02 plus 0.002 plus 0.0002 and so on. So from the first one, what we get is this number lies between 2 and 3. This is represented in this first part, that this number lies between 2 and 3. So we have magnified this region, and this point we are saying it is 2 and this point this is 3. So we have divided it in 10 parts. Next thing we need is 0.3. So the number that we have, it is after 0.3 and before 0.4. So we have marked this point as 0. This is basically 0.3. This is 2 plus 0.3 and this is 2 plus 0.4, and our number lies between these two numbers. So we have magnified this much portion now. Now the next thing is 3, 2. 3, 2 means our number lies after 2.32 and before 2.33. Our number lies after 2.32 and lies before 2.33. So we magnify this region now. This region we have magnified, and what we have obtained, this point is 2.32, this point is 2.33. Again divided it in 10 parts. Now what we know is that the number lies between 2.322 and 2.323, this region. Again we magnify this part. So likewise we continue magnifying these portions, and this procedure will never end. So we cannot precisely say where this number is lying on the number line, but we can represent the number. We can keep on magnifying the real number line. This is basically the denseness property of the real line, that as much as you need, you can magnify the real number line. You can stretch that line as many times as you want, because there are infinite numbers between any two numbers.